Okay, so this was... That is R perpendicular.
No, it's F perpendicular.
So what have we done so far? Step 1 was to draw the force. Well, we've done that. That was the weight vector. Step 2 was to identify the pivot. Well, we've done that. Now, step 3 depends on whether we're doing the left-hand method or the right-hand method. I've kind of done both step 3s now. I've drawn R and I've drawn R perpendicular. So we've drawn both of those. So we're done with step 3.
I see.
All right. Now, can you see why R perpendicular is going to be a much better approach here? Why is R perpendicular better? Well, first of all, do we know how long R perpendicular is? How long is R perpendicular?
How long is R perpendicular? Oh, that's because you gave us that length.
7 meters.
It's
7 meters. But do you see, we don't really have any idea how long R is. We have no idea how long this hypotenuse is. So that would be a difficult approach. It's much better to work with R perpendicular because that's the distance we were actually given. Also, if we were working with R, we'd have to know what this angle is. Remember, we'd need this angle to do trigonometry, but we weren't given any angles in this problem. So working with R would be much more difficult in this case. It's much better to work with the R perpendicular. Okay, so that's why we're working with this right-hand method over here.
Okay.
All right, so now I'm actually going to erase the R vector because we decided we're not going to use that approach. That's actually much more confusing in this case. All right, so I'll go ahead and erase that R vector.
Okay.
I guess I can redraw it.
You guys are using pencil, right? So you can erase stuff.
Well, we're using like a combination of pencils and colored pencils and highlighters so we can make different colors.
Ah, okay. I always recommend
okay.
to my students. I always recommend my students just. Most important thing is to use something that's easily erasable, because definitely we can be sure that we'll have lots of things we're going to need to erase as we go. And that's the most important fact. If you go back and recopy your notes later, you can do it in pretty pen and stuff. But the first time in your notes, it's important to be erasable. Okay. Especially because you might make mistakes, and also I might make mistakes, and you might need to erase that. Okay. So anyway, we have these. All right. Now remember, we've decided we're using this right-hand method. So what would we do next? Well, can you see that we're actually going to skip step 4, right? We're going to skip step 4.
We're not going to use force perpendicular.
Yeah, because we're doing R perpendicular. We don't need both of those.
Right.
Those are two alternative methods. All right, and now step 5 and 6 are the same as on the other side. So step 5, what was our step 5?
Determine the torque.
Actually, that's to determine the sign.
Of the torque. The sign of the torque.
So first of all, you have to choose what do you want to be our positive direction here, clockwise or counterclockwise?
Clockwise.
Clockwise.
So let's write that down. All right, now what type of torque are we going to get from this weight, clockwise or counterclockwise?
Clockwise.
So will it be positive or negative?
It will be positive.
Good. So I'll put in a positive sign. All right, so we've accomplished our step 5. We've determined the sign of the torque.
Okay.
What's step 6?
It is the vectors. It's the vector of torque.
I actually wrote it down wrong. Go back and fix your notes. Here we should not be. It shouldn't be the same as before. Now we should be doing F times R perpendicular, right? So we're not going to use the same formula as on the other side. So I wrote that down wrong previously. You should go back and fix that. Step 6 on the left-hand side was to use F perpendicular times R, but step 6 on the right-hand side is to use F times R perpendicular. All right, so that's what we're going to be doing, F times R perpendicular. So let's go ahead and do that here. What calculation do we need to do?
Hold on one second. Hold on one second. Okay, so what was the second one?
So instead of...
This is the first one.
Yeah.
And then this is the second one. F times R perpendicular. Yeah, okay. All right. Go ahead.
So so how would we do that here? What's the F? That's a little tricky here. What are we going to use for the F? What's the force?
Well, the force is just going to be the weight.
Which we haven't actually calculated yet. Remember, the weight is not 3 kilograms.
It would be the Newton. It would be 3 times 9.8.
Yeah, we should have calculated that already. So let's go ahead and do that. Let's figure out that weight.
29.4.
Good.
Newton.
Right, so the weight here would be 3 times 9.8, which is 29.4 newtons. All right, so that would give us our 29.4 newtons. All right, and what else should we plug into our calculation for the torque here?
For calculation of torque, I'm sorry. It's, okay, I gotta write the formula again. The torque, the magnitude of the torque equals the magnitude of the force times the R perpendicular. So then we do the plug in our R perpendicular.
7 meters.
Yeah. So we plug in 7 meters.
Okay, very good. So let's do that calculation.
Times 7. 205.8
Newton meters.
Newton meter.
Good. Positive or negative?
Positive.
We already decided that would be positive. Okay, good.
Uh-huh.
All right, good for us. We figured out the torque from the weight of the 3 kilogram object. It's 205.8 Newton meters. So here we have a torque of positive 205.8 Newton meters. All right, good. So that gives us that torque over there. All right. That's how we find the torque using that new 6-step method. So far, so good?
Yeah.
All right. Now I'm going to...
That's that. Oh, go ahead. So, did you get rid of the 4 kilogram on the left, or are we going to...
Now we're going to do that. So now I'm going to erase this picture.
Oh, okay. So it's like two separate problems, but one problem?
That's right. So far, we've only figured out the torque from the 3 kilogram object. Are there any other forces on this object besides the weight of the 3 kilogram object?
We've got the 8 kilogram
right
of this seesaw.
That's right.
And then, and then the 4 kilogram of the other blocks.
That's right. All right, so let's move on to that 4 kilograms. So first of all, so let's go ahead and, so we've got that weight over here. So now I'm going to draw a whole new picture now for that torque. Every torque needs a new picture because it's complicated. It's so complicated to find this. So I'll draw a new picture for that torque. So here's our new picture, and let's go through the method again. What's step 1 of the method when you're ready?
Draw the force vector.
Right, making sure you draw where it's being applied. So where is this force vector being applied?
It's at the center of the box down.
That's right. So center of the box down, there's that weight. And when I say draw the force, I really should say draw and, if possible, calculate the force. So let's go ahead and calculate that force right now.
Okay, so that's 4 times 39.2 newtons.
Good. So that'll be 39.2 newtons. 39.2 newtons. Good. All right, now what's the next step after we've drawn the force?
Identify the pivot.
Where's that?
It's right to the right of it.
At the triangle. Good.
It's at the triangle.
Yeah, we're pretty much always going to use the same pivot for all the different parts of the problem. So we've got that.
Okay.
All right, now what's step 3?
Is to draw your step 3 down. Draw your R perpendicular.
Yeah, because we're using the right-hand method. We've already decided the left-hand method is not very effective on this problem. So we're going to draw R perpendicular. All right, now that's a little bit tricky. So where would R perpendicular start and where would it end?
It would start at the center, the line that comes down from the 39.2 Newton force. It would start there.
Actually, it's best to think of it as starting from the pivot. Remember that R perpendicular goes from the pivot to the line of the force. It's better to think of it like that.
Okay, so from the pivot to the line of the center of the force coming down.
Yeah. Now where does it go?
From the pivot to the it goes from the pivot straight to the left.
Right. Straight to the left because it's supposed to be perpendicular to the line of the force.
Right.
So
straight across.
Here would be the wrong way to draw R. R does not go to the point of application of the force. This would be wrong because that's not perpendicular to the line of the force, right? Oh, so that would be R, and we're trying to draw R perpendicular. So R perpendicular looks like this.
Yeah, I was going to say that would be R, wouldn't it?
Yeah, that would be R, but we decided not to use that approach here.
Right, we're not using it, so
that
we
would
do
be
R
R perpendicular.
which would
That's
be
right.
Straight across.
That's right.
From the,
And why are we using that method? Well, for one thing, we know how long R perpendicular is, but we have no idea how long R would be. So it's much better to use the information that we know. Okay, so that would give us that. So that was our step 3.
Yes.
All right.
Hold on, right.
When you're ready, tell me what comes next.
So the next step would be to, why does it say skip?
So we kind of skip step 4. Skip step 4 we can skip, because step 4 on the left-hand side was to find F perpendicular. Well, we're not doing that anymore.
Right.
So we can skip step 4.
So we just go on to determining the sign of the torque.
Yeah, that's the same on both sides.
Here.
Determine the sign of the torque. So what would be the sign of the torque here? Take your time and figure that out.
Well, if you're pushing down on the left, it's going to go, the right will come up, so that'd be counterclockwise.
Counterclockwise.
So it'd be, yeah.
So the sign is?
Negative.
Good, good. The sign is negative. All right, so that's what that means to find that sign.